All right, guys, so start on the warm-up for me. Seeing if you remember what we just finished, and then we're going to build on that today with 11 more.
Oh, I love
See how you're doing. All right, so if we're using the first derivative test, we obviously need to take the first derivative, right? Okay. Did you guys do quotient rule? Did you rewrite it? What did you do? Quotient rule? Okay. Which simplifies to what? X squared minus 2x squared, so negative x squared minus 3.
That would be yeah.
Yeah?
What have you said there?
Oh, thanks. Yeah, never mind. Okay. How's that? Better? You what? Can I reduce that? Okay. So if I take out an x from each, what am I left with on the numerator? Negative x minus 6 over x cubed. Okay. So we need a number line, right? What are the values on my number line?
0
And?
-6.
Yeah. What would make the denominator 0? Okay, and it'd be undefined there, right? Anytime we get a fraction, you have to look at the numerator and denominator for what would make it 0 or undefined. So this one is actually a 0, and this one is undefined. Right? Okay.
I have a question. My equation equals 0 to x squared plus 6x.
Over negative x?
No, over x.
I don't know.
I don't know. I guess it's the same thing. Just
3 minus 2, 2 So it's always the denominator?
I got the same answer as you did. That's why I was confused.
Interesting.
I just
All right, guys. So then when we test our number line, were you okay with negative, positive, negative? Yeah. Right, and critical values are where your first derivative is 0 or undefined. Yeah. I'm not putting in stuff that makes the denominator 0. I'm finding my critical points, and that's where the first derivative is equal to 0 or is undefined. So that's the undefined piece. Okay. All right. So what does that tell me if I've got a negative, positive, negative? What would you tell me? What did I ask you? Increasing, decreasing? So where is it increasing? Where is it decreasing?
negative.
What if I ask you about maxes or mins?
What a negative 6.
And what is it, a max or a min?
That would be a max negative 6.
By maximum, do you mean minimum? Because if you're decreasing and then increasing, that creates a minimum. So we have a minimum And what is our minimum? Yeah. Okay. So if I plug in like a 1, I would have -7 over 1.
Oh, plug into derivative.
Well, you're testing the derivative. Because it's where the derivative is increasing or decreasing that tells us about where the original function, like where the derivative is positive or negative, tells us about if the first, the original equation is increasing or decreasing. Okay. All right. So where is your minimum? Like what is it? Okay. The x is -6. What is the actual minimum? Into the first one, yes. So what do you get when you plug a -6 in there? Okay, so -112 at x equals -6. Okay.
Yep.
Does that make sense? Okay, that's stuff we should know from last unit, right? No? Okay. So let's start with 11. All right, 11.1 deals with the second derivative test. Nope. Oh dear. We got 3 sections to go. You can do it. All right, guys, we're going to continue with the warm-up. So our warm-up, just a reminder, the f of x was x plus 3 over x squared. We did the first derivative and got, what, -x minus 6 over x cubed. We now need to find the second derivative. So I'm going to give you a second here to try to find the second derivative. How are we doing on the second derivative, guys? So Cece, what exactly? I mean, I see what's on your paper, but what? I know. So you're just intrigued.
What's the meaning? It's a graph like.
Oh, okay. I don't know enough memes. Like I see because I'm like, what? But I just keep looking up and then paper stuck to the camera.
Oh, I
Alright guys, I'm going to start going through the second derivative. So I would have x cubed times negative 1 minus negative x minus 6 is 3x cubed all over x to the 6. Yes, okay.
Read it out.
So that's negative x cubed, and then that would be plus 3x cubed. So did you guys get 2x cubed? And then minus minus, so plus 18x squared over x to the 6. Yeah?
Yeah.
Okay. So that could reduce to 2x plus 18 over x to the 4th.
Yup.
Alright. We hear that? 9. Close. Did you say negative 9 or positive?
Yeah.
Negative 9, yes. Okay, so we still look for critical numbers, okay? So your critical numbers, we're going to put on a number line. They are negative 9 and they are 0. It's still where the derivative is 0 or undefined, so derivative equals 0. Okay, so do your number line test. We've got some multiplicity here, so what's happening left of negative 9? Okay, first, where do we plug it in to test? The double derivative. That's weird. Okay, yes, the second derivative.
The left is negative.
Left of negative 9 would be negative, yes. Then what happens?
Whoa.
Positive. And after that? Positive. Good. 0 has even multiplicity, right, guys? So that means it would bounce off the x-axis. So if it's positive on one side, it's still going to be positive after. That's what that's doing. The 0, it has even multiplicity. So it's x to the 4th.
Oh, okay.
Yeah. So even multiplicity, so it bounces. I mean, it's technically undefined there, but it's bouncing. It's not going to.
Are we aware of this?
Because we learned about multiplicity a while ago. All right. So what the second derivative tells us about.
Okay. Oh, I understand.
Okay. It tells us about concavity. Like if your graph is concave up or concave down. Okay, we'll draw some pictures here.
It's just so useful every day.
It is. Absolutely. So when the second derivative is negative, what do you think that tells us? Concave down. Yeah, that means the original f of x is concave down. Tells us about concavity. So what about if the second derivative is greater than 0? What does that tell us about our original function? So like, let's just draw you. We'll do some more pictures, but like, let's think about the graph of x cubed. Okay. What is this point right here called? Point of inflection.
point of inflection.
Okay, yeah, point of inflection is what we're going to focus on now. And then this part of the graph, do you see how if I like continued this as a parabola, it would look like that?
Yeah.
That would be concave down. Okay, so that side is concave down. What do you think about then this side? You guys see how that's concave up?
Would there ever be one that's on the side?
It's what?
On the side, that's like square root.
Oh, that only has like one part?
Yeah,
So like a graph like this?
yeah.
Okay, that's concave down.
That's what I'm looking
Yeah, that's all. Like, you see how it's like an upside down? That's concave down, anything that's this way. So like, think about a cubed graph, or cubed root graph even. Or whatever shape you want. You see how like right in there it switches from being concave down to concave up? Okay.
There's a frowny face that's down.
Frowny face.
Wait, why is it up and down when they go sideways?
Why is it up and down when they go sideways? What do you think?
For the frowny.
I don't know.
So like, on the green one,
This.
it's going like this.
So it's not really going continuous.
No, not all the way down, but like it's going like it's going up, like from the x-axis.
So think if you, okay, it's up, but the shape of it, if you continued, you are not always going to see the entire thing if it's concave up or down. Like this is like half of it. But if you were to continue that shape, do you see how that's like a sad face, frowny face? If you were to continue this one, it's like, yeah, that's what you're looking at. Is it like a pole or is it?
Yeah, I was thinking like continuing it like going up, so it's kind of like facing like.
Oh,
Go
yeah.
back.
No, don't continue that one.
Okay.
Yes. Okay. I swear to say that.
Oh no.
It's like square root graph, it's not the parabola.
Right, so if you had this part of it, what would that be? Is that concave up or down? Yeah. Just look at it, like, could it catch rain or not? We'll draw more of them too. It'll be the first one. The blue and orange and green thing, yes.
Is it up or down or is it?
Well, one half is up and one half, like the left part is down, the right side is up. So yeah, so you're gonna tell me like it'll change concavity at all these different places where your second derivative is either 0 or 1. Okay. Maybe. Alright. So let's think a little bit about our first and second derivatives. We're sort of going to make a little chart here. We've got our first derivative. Yeah. For which one? Sorry. Like for the picture before? Oh. It's concave up. Where your second derivative is positive, the graph is concave up. So the actual graph for our original f of x here, which was x plus 3 over x squared, just so you can have an idea of what it looks like, there's an asymptote 0, and this side kind of goes like this, and this side kind of goes like this. I drew that really poorly because it should be concave down from -9. It's a bad sketch. But it's like from here to here is concave up. This is still concave up, even though it goes from increasing to decreasing. Is that what you're asking me about? No, so that is positive and this is positive. Those are both concave up. The negative is, so if the second derivative is less than 0, if it's negative, your original is concave down. If the second derivative is greater than 0 or positive, your original is concave up. So even think about like a graph that does like this. You could, that's going to be a minimum. This is concave up. This is concave up. Okay. Yeah. Okay, guys, so let's think about what these would look like graphically. Let's say your first derivative is negative, but your second derivative is positive. So what does the first derivative being negative tell me? Decreasing. Second derivative positive means? Okay, so that would look like that, maybe. I'll make a little sketch here. So decreasing but concave up kind of looks like that, right? Okay. With me. What if your first derivative is positive and your second derivative is positive? Okay, so that would look like that. You with me? All right, first derivative, let's do positive again. Second derivative, negative. What's happening there? So it looks kind of like that. Then first derivative negative, second derivative negative. Decreasing and concave down, so right. Okay. Wow, that's really I think the hardest part of this is understanding graphically how this is all coming together, and it's just, it takes time and it takes practice before you see it. We'll do some practice today with matching up. Here's the original graph, here's the first derivative graph, here's the second derivative graph, and just seeing if you can put everything together. We have a review day, I think. Did I put that on the calendar? Let's see.
Hey guys,
Yeah. Yeah, it won't. I don't think we actually have the fake quiz. I think it's just going to be working on the review in class. And then the quest. So. And then, guys, your quarter 4 test. I know we're getting off topic here, but that's okay. Does everyone understand the quarter 4 test is optional this time? Okay. So only if you need it, if you think you need it for a retake, or if you're planning to use your quarter test as your final. Is anyone planning to use them as their final right now? Couple? Okay. Remember also if you had all A's, and guys, if you have an A for the 4th quarter, A or A minus going into it, and you've had that every quarter, you're exempt from the final. Don't take your quarter 4 test, okay? Does that make sense?
oh wait, what?
Doesn't A minus count as an A?
A or A minuses are exempt from the final. All 4 quarters, yes? On the final exam day?
No, I'm not sure.
I mean, I mark you unverified if you're not here, but I don't care if you're doing that. If you're here, you would just be hanging out. Assuming you're not taking the final. If you have to take the final, but you don't want to take the quarter 4 test, then you could work on the review on that day. Does that make sense? I know you don't have to. As of now. You know, a few grades to go, but so far. All right, so are we okay so far with that? All right, so let's try another one. So, I don't know that we're actually on example 2, but we're going to say we are. All right, f of x equals 2x cubed minus 3x squared minus 12x plus 8. All the things I want you to tell me about f of x. Where is it increasing? Where is it decreasing? If they exist, what's your relative min? Relative max? Concave up? Concave down? And a point of inflection.
Whoa, whoa.
I think I skipped that from the last section. So guys, let's go back up here. I want to add one more thing. So we've talked about when it's the second derivative's less than 0 or greater than 0. If it equals 0, that's the point of inflection. And that is if the graph changes concavity. So what do I mean by that? Like, why wouldn't it change concavity? So it won't equal 0 if it's an asymptote. Right idea, though. What if it equals 0, but it's got like multiplicity of 2? Is the concavity going to change, or if it's up, is it still going to be up? Yeah, so if the multiplicity is even on that 0, then it won't actually be a point of inflection, but otherwise it would be. Okay? That's where it changes from like, so like our cube graph, that guy is the point of inflection. So it goes from concave up to concave down. Yep. All right, guys, so I'm going to give you a few minutes here. Try this one and see how you do. Well, you need the first derivative to figure out increasing, decreasing, max, min. And then you do the second derivative for concavity and inflection. Yeah. Oh.
So I have my zeros in the first derivative. You plug those into the original or the derivative?
Well, what are you trying to do?
Just find the increasing.
Like to find where the first derivative is positive or negative? So if you're figuring out where the first derivative is positive or negative, plug it into the first. Okay. If you're trying to find a max or a min of the original, plug them into the original. Okay. It does. It just takes a little time to like think through it, but it really does make sense. Promise. What?
When do you tell when it's constantly based on what you get from
So second derivative test.
Yeah.
Okay, so you do number line with critical point. And then you do the positives and negatives on it. Where that's positive, it's going to give up those. Okay. Because it's a min or max of the original, right? Okay.
So
So this is increasing to decreasing, increasing to decreasing. But if you plug in a negative one and zero, it's going to take a y value. Guys, I'll give you a little more time here. Keep talking to each other.
Do you have positive things? Bless you.
Okay, so we have one more example in our notes in like, because this is like, well, that's everything all in one problem, so. Yeah, sure. Sorry, I just didn't hear you. There's no 20. About negative 12? So you already found like your critical number. You already did it, right? Yes.
So then you would plug the one in. This one is 1/2 to execute this.
Good times, yes.
It's a lot of plugging.
It is a lot of plugging in. Yes, I agree. Yeah. There is a point of inflection. Okay, is the original line? No. The original graph, we're finding the point of inflection of the original graph. You do that by setting the second derivative equal to 0. It doesn't matter that the second derivative is a line. It still equals 0 at some point, right? Okay. It's intervals, just like increasing and decreasing. Okay.
So how would you say
It just is a point, like an ordered pair.
Oh.
Yep. So you're going to have to find the y. Oh, excuse me. Are you guys done with the first derivative part?
Yeah.
Okay, let me write those answers up just so you can check, see how you're doing. Make sure we're okay with that. Increasing was from negative infinity to negative 1. And from 2 to infinity. Decreasing, negative 1 to 2. Okay. Alright, you had a relative min of negative 12 at x equals 2. Don't just write the point. And your relative max was what, 15? At x equals -1? I will take a little bit of points away from you. Because this way, like for the calculus exam, sometimes you can get away with just saying the y value, like what is the minimum? Well, it's -12. Sometimes they also want to know where it is, so if you write it this way every time, like what is it, where is it, you'll get it right. Okay, so it's like the safe way to write your answer. How'd you do on the first derivative stuff? Good. Okay.
So I was waiting for the
Instead of like the graph is going up, the graph is going down.
So like on, let's say this was the second program, so like from what would you say?
So from -2 to -1.
Yeah.
You answer the
Okay. So do you not have to like plug these numbers back into your
That's how you get the
okay.
Seriously. Oh my god. Stop me.
Okay, so one after you have Guys, another couple of minutes here, then we'll look at the second derivative stuff, okay? Yes. What about him? Concave up was from half to infinity. Concave down is -infinity to a half. And your point of inflection, this is an ordered pair. 1/2, 3 halves. How do you get the y? Yes.
Oh yeah.
So yes, you're gonna plug a half into that original.
Yeah, I read the whole thing like 5 times.
I don't think so. You can do it.
Dad had a crush on Ice Carly, who was like really like tech savvy and like.
Okay, guys, let me put the answers up, and then we'll go through any issues. So concave up should have been from 1/2 to infinity. Okay. Concave down, negative infinity to 1/2. All right, then the point of inflection. Guys, this is a point of inflection from your original graph. I'm asking you for a point, so yes, you can just tell me ordered pairs. Whoa. It is 1/2, comma, 3/2. How'd we do? Good? This is 11/1. So, yeah, that's today. So the three things we have this. I actually think this with the graphs is probably the hardest part of the unit. Yeah. 11/2 is implicit differentiation. It's just more derivatives. It's just like another rule, kind of like power rule change, that sort of thing. And then the third one is the trig derivative. So like first derivative of sine.
Like on the top, see if the number ever goes to the first.
But yeah, you got to remember all the first derivative stuff too. Yeah, 10 and 11 definitely go together. If you struggled on 10, you gotta get that sorted. What?
Everyone here took a test.
Yeah. Well,
Uh-huh.
can you take the derivative? There was like a section in your notes where you talked about quickly. There were 3 cases where you couldn't. If you get out your Unit 10 packet, I'll show you. So guys, things to note on this. When you are finding the min, the max, or the point of inflection, that is where you plug x into your original f of x to get y. Okay? And doesn't that make sense? You're looking for the relative min or max or the point of inflection of the original graph. So wouldn't it make sense to plug it into the original? Okay. Try not to memorize these things. Try to think about it and be like, well, okay, like that's why I do that way. Whereas when you're testing, like increasing, decreasing, you're testing your number line. It's the number line of the derivative, so you're plugging it into the derivative when you're testing. Okay. All right. We have one more example. Okay. So. I don't like how I do that, sorry. Let me start over. Yeah, it's just an hour and a half. Okay, I know it's tilted and I'm sorry. Purple is your f of x. I want you to try to sketch. I'll be doing it in orange. The first derivative. And does the green show up okay for you guys? And the second derivative. Now, this is where you gotta put it all together in your brain, okay? Think about what the first derivative tells you. Think about what the second derivative tells you. Definitely draw the first derivative before you draw the second derivative, okay?
How do you draw a derivative?
You should be able to sketch it. So that's the original. With the original, I can look at it and I go, oh, I know where it's increasing, decreasing. I know where max and mins are. I can see pretty well where it's concave up and concave down.
Wait, so where should we put derivatives? Like the first
On the
derivative?
same graph, you should draw those. That's why I have different colors, because I'm going to draw all 3 graphs on the same
Yeah,
grid.
but like, can't you put a first derivative at any point on there?
Because where your first derivative equals 0, meaning where it's on the x-axis, is pretty important to, like, that has a purpose. Right? Yes, you're going to lunch in like 3 minutes. So we are not going to go through this until after lunch. Okay, guys, let's look at this. I think those of you that were going to draw it have drawn it, and those of you that were scared are still scared. So let's look. So, is that an accurate? Okay. All right. First derivative. What does the first derivative tell us about?
The slope of change.
Okay. And what else? Okay, critical points. What do critical points tell us about the original?
Maximum.
Okay, so I see a max here, I see a min here, I see a max here. What would be happening on my first derivative at those maxes?
0.
Okay, so I know I've got a 0 there, 0 there, 0 there, right? Okay. As I start over on the left side of my graph there, is it increasing or decreasing, the purple graph? Increasing. What does that mean about the graph of my derivative? Will it be above the x-axis or below the x-axis? Above. So I know that something like that is happening. Okay? Then between my max and my min, what is the graph doing, the purple graph? Decreasing that whole way, right? So where is my orange graph going to be? Below the x-axis. So it's somewhere down here. I don't care right now about where it crosses the y-axis. That's not really a concern. Wow, that's such a bad line.
Will you ever ask us to do the y-axis? For a question like this?
I mean, I could, but with this, no, because you don't actually have the equation. What's going to matter is like the concavity and stuff like that. Can't draw it. Okay. And then what's happening between my minimum and my second maximum? Increasing. So what is my graph going to do from this orange dot to the last orange dot? That's going to be above the x-axis. Okay. And then what about after that? Going down, right? Okay. Couple things to look at. If you look at the purple graph, the original one, do you see how we have 3 either maxes or mins? Okay, how many do I have on the orange graph then? 2, 1 less, right? How many do you think I'm going to have on the second derivative? 1. 1 less, right? 2 minus 1 is 1. Okay. How do we do on the first derivative graph? Does it make sense to you? Yeah.
Within the rules, like if it's above the x-axis but increasing, it's decreasing.
So, I mean, it's a lot to write down. It's a lot of words to write down. If f of x is increasing, f prime of x will be above the x-axis. If f of x is decreasing, f prime of x will be below the x-axis.
And if it's increasing, will be increasing above the x-axis?
Those are two different things. If it's increasing, if the original is increasing, doesn't matter where it is, above or below the x-axis, the first derivative will be above the x-axis.
And what will it be facing? Like increasing or decreasing?
Okay. So you've got to get, like, I would always start with your zeros, your critical values, okay, so that you know, like, this had to be going down because I had to get to that. You know what I mean? I mean, it's decreasing above the x-axis. Here it's decreasing and then increasing. Here it's increasing and then, you know, like that's. So just think above or below based on increasing or decreasing from the original. Okay? All right, we still have our second derivative to look at. So, there's a couple of ways you can look at this. What does the second derivative tell us? Concavity, yes. Good. So we're looking for where the purple graph changes in concavity. What else could we be looking at? So let's pretend the orange one is our original graph. Then the green would be our first derivative. Right? Okay, so let's look. Do you see that I've got a minimum sort of right there on my orange graph. Doesn't that look like it lines up pretty well with where the purple graph changes from concave down to concave up? That means that's a 0 of my second derivative. Okay? You can look maximum of the orange one, which is going to be the same as where the purple one changes from concave up to concave down. That is where my second derivative is equal to 0. Okay? And again, I don't care if you use the increasing, decreasing of the orange or the concave up, concave down of the purple. Like, you should be aware of both of them. If you look at this whole purple section of graph, from there all the way to where this green dot is that concave up or concave down? Down. So where is my green graph going to be? Below the x-axis, right? Okay. What's happening in here? Is this concave up or concave down? So where is the green graph going to be? Above. This concave down. So I just got this to be below. So it just looks kind of like that. And again, purple had 3 max or mins. Orange had 2. Green now has 1. Sure. We could do one solid, one dash, one weird dots or something. An invisible. My invisible graph is the second group. Perfect. Alright. Question. You get to what I mean? I think this is the hardest part, like understanding the graph. Like this is, it just takes practice. Talk yourself through the pieces. Okay. What?
This is weird.
Because this had to be below the x-axis, this had to be above the x-axis, and this had to be below. Because concave down, concave up, concave down. No? Okay, let's look at the orange graph. Decreasing, right? So that section has to be below the x-axis. Increasing all the way to there. Well, all the way to there has to be above the x-axis. And then decreasing, so it's got to be below. You could do the first derivative rules from the orange one. The second derivative is the first derivative of the first derivative. You know. Yes. Okay, so that is where the concavity changes from the purple. So do you see concave down, and then somewhere it turned to concave up, right? It's like partway in between there. Okay. It's also going to line up with the maxes or mins of the orange graph. Okay. Okay, guys, let me stop here.